Our next panel is entitled, How does the science of antibiotic resistance and use get applied in veterinary farming practices? And we have a very distinguished panel here from multiple species today to go over those topics. Kind of following in tune with what we had in the last panel with the discussion of stewardship programs and how they apply their measurements and look at their metrics. We're going to have a little bit of that discussion here today, as well as knowing that, as Dr. Barker mentioned, human medicine and veterinary medicine have some commonalities in that we both focus on disease prevention. Immunizations are all common things that we work to strive to get the healthiest animal or human that we can get in any of our systems, whether it be HCA with Dr. Septimus or whether it be Pipestone with Dr. Nerem here. So we have some real commonalities, and part of the symposium is, of course, to realize those and work across the table to discuss that. So we encourage questions and the networking opportunities. First and foremost, we have, we'll say that for Dr. Morgan Scott. Dr. Scott was at K-State one time. I have to say that every time with my K-State lanyard. He is currently he received he's a veterinarian and a PhD. Has been in private practice, food safety surveillance, epidemiology, about any type of thing. You've tried it all, right? On there. Currently, he is a professor of epidemiology in the Department of Veterinary Pathology at Texas A&M. His main goals or hopes to identify opportunities to prevent and intervene against resistance among enteric pathogens in animal agriculture, preferably by developing readily adoptable and cost-effective management practices suited to the modern animal and food production systems. So with that, I'll turn it over to you, Dr. Scott.
Thank you. And I appreciate the opportunity to speak today. I think that of the panelists, I'm the least qualified to ask the question or answer the question, how does the science get applied in veterinary and farming practices? I've been out of practice now for, I think, 20 years. I'm largely a researcher, and most of my research, again, focuses on enteric bacteria. But I do think I can address, I guess, rhetorically, how might or how could the science of antibiotic resistance and use get applied in veterinary and farming practices. And since the examples I'll use come from beef and dairy cattle, I think I'm supposed to represent that commodity up here today. Many of you are probably aware that just over 2 years ago, the World Health Assembly adopted the World Global Action Plan of 2015, and this followed several years of preparations. I highlight there's three objectives in the middle: to strengthen knowledge and evidence base through surveillance and research, to reduce the incidence of infection, and finally to optimize the use of antimicrobial medicines in human mental health. The previous panel obviously addressed objectives 3 and 4 quite thoroughly, as well as the ones I haven't talked about, improving awareness and obviously sustained investment in this problem. This is a map that I reproduced about 3 weeks ago. This is self-reporting to the tripartite of the OIE, FAO, and the World Health Organization. Dark green is, I guess, really good. This is self-reporting the integrated approaches that are being implemented to monitor progress on national AMR plans, so national action plans to supplement the global action plan. Red, of course, means nothing's going on, and gray is no data, or no data. You'll note that the U.S., along with some Nordic countries, Australia and China, self-report as being making great progress, and many other countries are somewhere in between. Obviously, that means, of course, we have a national action plan that you probably are fully aware of. You may also be aware that there was a change in leadership in this country 10 months ago, and that has resulted in multiple changes in policy in many areas. But interestingly enough, so far as I'm aware, we still have a single national action plan that was brought in about 2 months before the global action plan. And of those, of course, it has to be 5. If you try to map those to the WHO list, you will find that 1 and 2 map quite slowing the emergence of resistant bacteria and preventing the spread. strengthen One Health surveillance and research. 3 and 4 are somewhat different. They're almost sort of more technological innovation, investment and development, and so on. And 5, of course, is international collaboration and capacity development. Why I'm mentioning these is because one of the things that these plans do when they prescribe 5 or 6 action points is it's difficult to prioritize, and they're necessarily vague. They don't really help us decide, well, what exactly should I do, whether I'm a veterinarian or a producer, a policymaker, to actually affect change that will meaningfully impact resistance. The other problem is that most of these solutions tend to be technical. They rely on science, and as a once great ecologist said, who has this famous one-sentence abstract in a Science Journal article cited 35,000 times called The Tragedy of the Commons, the problem has no technical solution. It requires a fundamental extension of morality. Now, whether or not you agree with his problem, which was what do you do with a limited resource pool when everyone's trying to extract from it, in this case you could argue that the bacterial problem is this issue of susceptibility. And those who've heard me say this before, we talk about stewardship of antibiotics, but in fact, we are being stewards of the bacterial population. That's what we should aim to do. In fact, the fundamental extension of morality is being applied, whether you like it or not. The statement on the left, to preserve the effectiveness of antibiotics, those are my words, we simply must use them judiciously as possible. On the right, preserving antimicrobial effectiveness in the future through ethical practices today. These are the statements that gave rise on the left to the FDA's Guidance for Industry 209 for Professor Sharfstein. On the right, this is the mission or vision statement associated with McDonald's global vision for antimicrobial stewardship. These are statements of moral imperative and a vision of ethical practices. Ethics being essentially the guiding practices of professions such as veterinary medicine, human medicine, it can be agriculture or any other similar approach to raising animals in today's environment. So if we look at what human medicine does, and of course I'm not a physician, so I'm generalizing, but this is a statement from the Infectious Diseases Society of America, that stewards of antimicrobials seek to achieve optimal clinical outcomes relating to use, minimize adverse events, reduce costs, and limit selection. So that's an aspirational statement. And if you imagine a patient presenting with, in this case, Streptococcus pneumonia infection, the physician, in this case Dr. Stu Ward, will choose an antibiotic that's appropriate for that infection, either empirically using existing antibiograms for the region, or ideally based on culture and sensitivity. It turns out that that patient, especially if they're aggregated with many other patients in intensive care units, will have other bacteria in the body. The microbiome, of course, is the buzzword of the day, but if you use an antibiotic anywhere in the body, chances are you're affecting bacterial populations somewhere else. And in the case of nosocomial infections in humans, that is essentially intestinal bacteria. The Klebsiella, the Enterococci, and other bacteria that can become a real problem in intensive care units, nursing homes, and so on. This is the key to the problem that we face in animal agriculture. The reason I've spent all this time leaning towards this point, which is we have suggested action plans, we have moral imperatives, we have ethical frameworks. We think we know what being a good steward is that in veterinary medicine and production agriculture, we have 2 outcomes of concern, much more so than, for example, in clinical salon practice or human medicine. We're treating respiratory disease or preventing it, we may be controlling it. We have 3 primary pathogens of Lyme respiratory disease, Mannheimia hemolytica, Pasteurella maltasa, and Haemophilus somnus. We're using antibiotics that don't just target those bacteria, but they also target enteric bacteria like Salmonella, E. coli, and Campylobacter, and you can't separate out the 2. I mean, the ideal drug would only find its way to the lungs and it would have no effect in the gut. Okay, but we don't have those bacteria. In fact, one of the advantages of having antibiotics that work everywhere in the body is you can have multiple indications. So on the left are data from the Kansas State Veterinary Diagnostic Lab concerning Thalassemia and macrolide resistance from 2008 and 2016. There's 3 bacteria. The purple one, of course, is Kansas, is Mannheimia hemolytica, and you can see some pretty high levels or prevalence of resistance to that macrolide antibiotic among these BRD pathogens submitted to the diagnostic lab. And yes, diagnostic lab samples are biased because, of course, we may have treatment failures, but the point is, if you were a veterinarian, consulting veterinarian relying on antibiograms to decide on first, second, or third choice of antibiotic therapy, that might guide your decisions towards something like ceftiofur, which at KSBDL they have not reported any. Now, there are interpretive issues associated with ceftiofur, but imagine for a moment that that would be the drug that you would choose to avoid this problem, and you would be a good steward. However, on the right side, you'll see old NARS data going up to 2008, where we see after the introduction of this class of antibiotics in 1988, an inexorable rise among all salmonella prevalences to ceftiofur. In this case, it's mostly the lactamase 7-mycinase 2 gene, or CMY2. That has since changed. But the question would be, on balance, what is the correct choice? Should you be a good steward and choose the antibiotic class to treat the BRD? Or should you focus on the enteric bacteria and worry about the salmonella and the prevalence of resistance among the enterics that pose potential food safety problems? It's a lot more complicated for a veterinarian and a producer. In many ways, it's somewhat similar to what goes on in the intensive care unit of a hospital, in that you have to deal with the immediacy of recovering the patient with strep pneumoniae, but meanwhile, over time, you're causing Klebsiella, E. coli, Enterococci, and others to accumulate resistance that can become burdensome. The late Dr. Scott Ward of Iowa State University suggested that we can capture some ownership and frame it ethically as the release from the farm model that he published in Microbe in 2006. I've blocked out in blue the farm, the use of the antibiotics, the selection for resistance beyond baseline, and the idea that so long as resistance doesn't escape from the farm above levels of baseline, we are being good stewards, potentially, of antibiotic use. This has much appeal. Besides the linear nature of it, it suggests that not only do we worry about the food supply, but we also need to worry about the environment, including water, soil, manure, and so on. The problem this poses is, what is the baseline? And we've already showed you that over time, resistance can rise. So what is the appropriate baseline? And the second thing is, if we know that there are dynamics associated with use that increase the levels of resistance past the baseline, should that impact our decisions? And our decisions shouldn't just be about treatment, but they might be about when we send these animals to slaughter. These are unpublished data. They're a bit complicated. But on the left, you have the profile among a bunch of dairy cows given the labeled double dose of ceftiofur. The blue line is a reduction in total E. coli per gram of feces. These are wet grams, so it's not quite the log 8 you expect to see. But we see that if we use the drug, we reduce the total number of susceptible E. coli. And the red line is an increase in the count of resistant E. coli, that is resistant to third-generation cephalosporins. I draw your attention to the vertical line, black line, which is day 16, and I ask you that if that red line is elevated past what it started at, is it reasonable to suggest that that animal should be sent to slaughter with elevated levels of resistance to a critically important antimicrobial? On the right is a single-dose treatment of steers, but in this case used anaphylactically, so every animal in the pen was treated. And you can see that the rise is pretty much mapping the double dose, except that it's extended in this recovery. Now, I don't worry as much about the right side, because beef cattle tend to be 150 to 180 days, potentially post-arrival until they're going to slaughter. But the dairy cow on the left, if there's treatment failure, may be likely to go to slaughter. And so the question is, as veterinarians and producers, do we have an additional obligation beyond choosing the drug to make decisions about withholding animals from slaughter? So finally, I want to close by suggesting that there's a framework to put all of this action plan into action. Excuse the pun. This is a framework from the European Environmental Agency, developed in the 1990s. The acronym is DPSIR. It stands for Driving Forces, Pressures, State, Impacts, and Responses. And this may seem unnecessarily complicated, but if you think about environmental issues, you have causes, you may have pollutants that could decrease the quality of air and water. This kind of impacts on health and ecosystems, and finally, society and policymakers may respond. I ask you to think about the idea. We're frozen now.
Scott, you got it?
the idea that the causes, in this case, and this perhaps the global action plan, are rates of infection. So if we can somehow reduce rates of infection, we can reduce, in this case, the pressures, which are the antibiotic use, which can impact positively the state, which is the levels of resistance. The impacts, of course, are treatment failures and so on. And finally, the responses can be applied to all 4 of these. Why this is important is it recognizes that we need to be targeting all of these. Like, we don't have to do all of them at once. We don't have to prioritize them equally. But we may be interested, in particular, in reducing infection, reducing antibiotic use, and yes, ultimately reducing resistance, but that can be intractable in many cases. The 4th area, which is the impact, is the other reality that we face going forward, in which we may need to learn to live with resistance. We may need to define what are the aspects of resilience that we need going forward. So if you're a hospital director on the human or veterinary side, if you're a producer and resistance arises to a certain level, we can't expect it to go away overnight. And so all of our responses should be suited to not only those initial 2 on the left, which tend to map nicely to the action plans, but also to how do we actually learn to live with resistance. So with that, I'll pass the baton. I appreciate your attention.
Thank you, Dr. Scott. Thank you, Dr. Scott. Next, we have Dr. Donna Carver. Dr. Carver, as with Dr. Scott and Dr. Nerem, their bios are listed in the program. We'll highlight those as we go through. Dr. Carver got her DVM and PhD from North Carolina State. Her specialties are poultry medicine and epidemiology. Her goals are to correlate on-farm levels of Campylobacter with levels in the processing plant. Additionally, she does work involving identifying risk factors on farms. So with that, I'll turn it over to Dr. Carver.
Okay. Thank you. Is it on?
Yeah, I slide a little bit closer to you.
I'm pretty loud. Can you hear me? Can you hear me now? Okay, good morning. I'm very happy to be here this morning. I am, in fact, a trained epidemiologist. I do not deal with a lot of antibiotic usage. So as an epidemiologist, my first thought when my department head asked me to come to this was, I'll just do a survey of everybody who does antibiotics. And so I sent out surveys, and much of what I'm going to talk about today is really the things that I heard when I was talking to people about how they feel about being the person in the company that has to really do this stewardship, okay? So I'm going to start a little bit with talking about some of the reasons that the poultry industry has been working in this area for a very long time. The conundrum that we have is that we want to, number one, everything I say today, I want you to realize that we're trying to protect the antibiotics so that they are susceptible, so that bacteria are susceptible when we need to have the antibiotics in animals and especially in humans. And that's why we're all here. But when I say things, that's always going to be the number one. We also have to protect the welfare of the birds, and I don't think this is so much of a problem in human medicine because you're just going to treat people when they get very sick. We also have to try to protect our markets, and they are very diverse at this point, and I'll talk about that. And sort of a philosophical thing that I'm going to talk about through here is that, you know, we've got to improve the public perception of our products and what all of these terms mean that we have on our chicken package. I mean, if you go in and look at the chicken, it's like, wow, you know, there's so many different things that they're telling you about that. Okay, so the issues that are related, in my mind, to antimicrobial stewardship in poultry production are really that much of this is placed on the shoulders of the veterinarians. They are the ones in the company who make the decisions about not the markets and the inputs necessarily, but about the health of the birds. And the animal welfare and the veterinary oath that everyone took right when they were trying to graduate there, it's sort of in contrast to not treating animals that need to be treated. And I'm talking about birds, but I think this is the case in all of the animals. You have this, are they sick enough that I need to treat them? And I'll talk about what happens once you treat antibiotic-free birds. Veterinarians have a lot less tools in their toolbox now in terms of treating infectious diseases that are susceptible to antibiotics. Most of what is done is prevention. Prevention has been the mainstay for many, many years. Vaccines, those types of things, biosecurity. But now they're moving to, when we talk about science related to antimicrobial resistance, a lot of the companies are moving to doing studies and trying to look at different botanicals and other types of things that could help either prevent or treat some of these diseases. There's conflict between antimicrobial free and animal welfare. I've already alluded to that, but there are groups out there who are trying to influence that. And then I'm going to just start out talking about this, that much of what has been done in the poultry industry is market-driven. Everybody is in business to have a market that they can fulfill what the market wants, okay? So that's been an issue. So if we look at this graph, you can see that back in 2013, and that really wasn't that long ago, we didn't have a whole lot of antibiotic-free poultry flocks. But what happened was Chick-fil-A and a number of the other markets said, we want to serve only antimicrobial-free chicken. So the industry really rose to the occasion, and they started trying to raise these birds with no antibiotics. And it is very difficult to do that. So I think as you see, and if you look, 2022 on the bottom graph is not as far over as 2022 on the upper timeline because I'm not smart enough to make that happen, okay? So just pretend that the blue line is longer, all right? So then the next year, in 2015, McDonald's, as we've already seen up here, said, everything's going to be antibiotic-free. And that is their marketing strategy, okay? That is what they think people want, and so that's their marketing strategy. Then some of the urban public schools said, oh, well, we're not going to serve anything that's not antimicrobial-free. Then I put UMass here. I'm not picking on anyone from UMass, but they were the first university to say, we want it all antibiotic-free. So as you can see, as the pressure was building, more and more flocks were being raised antibiotic-free. But it's not easy to do that. Then the animal welfare people came in and said, wait a minute. You can't deny these birds antibiotics. They're sick. That's an animal welfare issue. So the SPCA also chimed in on that. Some of the food safety groups said that trying to raise birds without antibiotics was increasing the prevalence of salmonella and shedding rates and that type of thing. Then the AAAP, which is the American Association for Avian Pathologists, came out with a statement that judicial use of antibiotics could not you couldn't use marketing to not take care of the animals. You had to use judicious antibiotics, use of that, in order to keep the birds healthy no matter what your market was asking for. Okay? And then we have the FDA. All right, so we got like all of these different groups trying to influence this whole situation. So when you look at the players, and I thought we had a lot, but then when I saw that whole human medicine thing, maybe we're not in bad shape. But if you've got effective antibiotics, and that is the goal, right? That's why we're all here. We want to have antibiotics, and when we use them, they work. And at the top of the triangle, that's the antibiotic-free, and then no antibiotics ever. That's one of the new terms. No antibiotics ever for these birds. And so that's what we're seeking, and part of most of that, a lot of that is because of the markets. The markets are demanding it, and so we have to try to do it. But then we have to also think about the animal welfare. We have the human medical people saying, you know, a lot of this is the fault of the, food animal veterinarians. I'm not sure that's been proven, and I don't know whether that's right or not, but there's pressure there. The AMR is putting pressure on in terms of, animal welfare. And then there are groups that just don't ever want animals to be consumed by people. And so this is what we're dealing with. It's not just a matter of let's take the antibiotics away from the poultry flocks, to preserve this susceptibility in the bacteria. So we've got pros and cons. I always tell my students, before you do anything, think about the pluses and the minuses, because they're always there. The pros for this are that we can meet the market demands, and that's very important for a business. You also reduce the food animal exposure to the antibiotics, and you might even over time reduce antimicrobial resistance. Question. I don't know if that happens. With Campylobacter, it seems that if it happens, it's going to be a very slow process. Okay, we have had Campylobacter that for the fluoroquinolones especially. They don't just, you take the fluoroquinolones away, they don't just, snap back, okay, and they're susceptible. The cons are you have increased cost of production. You have increased feed conversion, which is how many pounds of feed an animal has to eat to convert it to muscle or meat. The live weights, it takes longer to get to live weights, so it takes longer to get to market, and it's just expensive. It's just very expensive. You also, and this is something that the veterinarians stress to me, you get increases in things like necrotic enteritis that you can't treat. You get, in turkeys, we have a disease that is called blackhead histaminiasis. The drugs to treat that were taken away a while ago. The drugs to prevent that have now been taken away. And so when these birds get sick, they're sick and they die from liver failure, so it's a very difficult thing to watch. So you have to cull most of those birds. You also can get the increase in salmonella shedding, which I've already said. Okay, so what are the trends? If you look at this slide, it's kind of difficult, but from 2013, oops, that wasn't the right one. Oh, I can't shoot it at that. Okay, bottom line 2013, top line 2016, and what we're looking at here are the 4 strategies that people in the industry use. Full spectrum means they're still doing using whatever they have, at whatever need that they have. Okay, so the antibiotics at hand are being used. Reduced use means that no medically important antibiotics are being used in these flocks. Ionophores only means that the ionophores, which are there to prevent coccidiosis, which is a protozoal organism, they're used, but nothing else. And then the last group is no antibiotics in feed, and this is all feed. Okay. So the shift that I want you to see is that the red, which is where people just continue to use antibiotics the same way that they have, the ones that are still available, has actually reduced since 2013, which is the bottom one, up to the top one. And if you look at the green one, you can see that that's no antibiotic use. That has increased over time quite a bit, and this is what we want to see, okay? If we can raise the birds in a way that's a good welfare type situation. So what happens to these birds when they get sick? Okay, they're being raised antibiotic free. They get sick. The veterinarian has to decide, when do we treat them? Once they're treated, they're not antibiotic free anymore. I mean, that makes sense, right? So the antibiotic has to think, well, we've got these birds that are going to give us a high market price, but now they're sick and we need to treat them. What's going to happen? When they are treated, they are marketed with the birds that are just commercially regular strain birds going through without the tag of antibiotic free. Well, that group of birds doesn't get, they don't get as much money for those. So you've moved those birds that you've been raising in a more expensive situation into a group that are not going to be very lucrative. So that's what happens. And if the birds that you're moving are pretty close to, market age, you've put a lot of money into those birds, and then they have to move into a group where you're not going to get the money back out of them. Now, not all companies have this way to put the birds into the conventional lines. There are a few companies that only raise antibiotic-free. So these are very costly things that really the veterinarian has to decide, is this going to happen? Okay, markets. Right now, and this is something we have to think about, right now there are two markets, really. There are the markets where the people who want, are willing, and can afford to buy the chicken that is antibiotic-free that costs a lot more than the chicken that is not antibiotic-free. So we're starting to have two populations of people that based on the price of the bird, okay, or the desire to have an antibiotic-free bird. Excuse me. Now, I want to say a few things that we hear all the time. We hear things about people come up to you at cocktail parties all the time. I know they do. And they ask you about this stuff, okay? I don't know, maybe yet they don't yell, but they do, poultry people, okay? They come up, they want to know, all these different things. They really don't, due to the antibiotic residue monitoring, which has been going on since before I went to vet school, so probably 40 years. Animals are monitored at processing for antibiotic residues. And if they're found to have those, then they aren't processed, they don't go into the food chain. So when people come up to me at cocktail parties and they ask me, I don't go to that many actually, but they ask me about chicken and if they are eating chicken that have been treated with antibiotics, are they eating antibiotics? Well, no. That whole thing's been taken care of, 40 years ago, okay? But they don't know this, okay? So that's the kind of question that you get out there. And the reality is that is not the case, okay? People are not eating antibiotics when they eat animals that have been treated with antibiotics. There are withdrawal periods. So I guess the point that I want to make with that is there's really a lot of misinformation out there about antibiotic use in all of the animals. Okay, now, so the market for antibiotic-free birds is growing, as we just saw. The cost of production is very much higher than it is in the birds that are allowed to be treated. And the variable costs that go into raising these birds, they're not fixed, okay? So, the price of corn, the price of soybeans, if that goes way high, then what's going into producing these birds is going way up. Okay, so my point here is, if that occurs and corn shoots up because of whatever reason, and the companies have to buy the expensive corn and feed that to the animals, then the cost of production is going to go way higher in the birds that are antibiotic free. And when that happens, what happens with the markets? Is Chick-fil-A going to say, oh, well, we still want to have the antibiotic free, so we're just going to raise our chicken sandwich to $9? I don't think that's going to happen. I think that what will probably happen is some of these people will go back and start using some of the other birds that have had antibiotics, okay, and got to market much faster. All right, the attitudes are changing. We're all here now talking about it. That means that attitudes are changing. We're talking. We're trying to figure out what each group's role is going to be in this, and that's important. I want to let you know that also the research areas of the industry are changing. They don't, when they come to us at the university and they want to study, it's usually not something like, what antibiotics should we use here or there or whatnot. It's things like, can we look at the microbiome in these birds? Can we see if there's something in the gut that we can change naturally that will help us with necrotic enteritis? Okay, so the whole mindset is starting to change because of this market. It's driven by the market. Prevention has always been stressed, so I can't really say that that's changing all that much, except that they are looking more closely. The other thing is that the veterinarians that I talk to feel like the antibiotics that they have, they don't want to use them. They don't want to use them because they don't have many left in their toolbox, and really they don't see anything coming down the line that's going to actually help them. Any new antibiotics that are developed will probably be human only. So they're really trying to make sure that this doesn't happen. All right, this is really where I'm going to get to the end and sort of philosophical stuff. Be honest, all of us up here, with our products. We need to be honest about our products. We need to talk about them. We need to let people know that they are, for poultry, an inexpensive source of protein, healthy, safe, raised under conditions that meet the market demands as much as possible, but welfare issues, okay? Hormones, I get that at every single cocktail party, okay? Hormones. Hormones have not been fed to poultry. That's my drum roll. Since 1949. Okay? So, there are no hormones. What happens is, in order to market products and try to diversify the products, some people will say, our birds are raised with no hormones. And that is true. They put it on the package, it's true. But it implies that some birds are raised with hormones. And that really confuses people. It really does confuse people about the whole issue. So I think if all of the food animal people could work together and not make statements that confuse the issue, because this antibiotic thing is the one that's really important. That hormone thing, it's not important. It's not there. So we need to try to do that. The eggs from free-range birds are not better than the eggs, it's been studied, they're not better than the eggs from cage layers. More humane, perhaps. And that one I've already said, when you eat meat, you're not eating antibiotics, okay? So I think that if we can, and I'm going against what I've heard earlier, and I'm sorry. And you're right, education is a difficult thing, but I think we have to educate people for the birds, that all of the birds that are produced are hormone-free. That, you know, if they're antibiotic-free, that doesn't, or if they've had antibiotics, that doesn't mean that you're eating antibiotics. We need to educate people that, you know, what they're eating is safe. And then I think that we also, one last thing, I think that we also, and I think that the physicians can do this too, try to educate people that the critical control point for food safety is how you handle and prepare the food. And we live in a society where children grow up, mine included, and they never cook, they never know anything about cooking, and I think home economics should be mandatory for high school graduation.
Thank you, Dr. Carver. I think we'll rename the reception tonight the Dr. Carver Cocktail Party. How's that? So, that would be good. Last but not least, we have Dr. Joel Nerem from Pipestone. Dr. Nerem received his DVM at Iowa State University in 1996 and is currently serves as the health director for Pipestone Systems comprising 200,000 plus sows, wean to finish, sows and wean to finish operations. So Dr. Nerem as well as Dr. Scott have both previously spoke to our symposium before, so we look forward to hearing from Dr. Nerem again. Thank you.
Thank you, Dr. Moore. I appreciate the opportunity to come back today. A year ago, I was on a panel similar to this one, representing the pork producers, the pork production industry, talking about how we use antibiotics in a responsible way. Today, my comments are not representing the pork industry, but are more representative of our veterinary practice. And I want to tell you about how we are attempting to use the science of antimicrobial resistance, antibiotic use within our practice, and hopefully demonstrating some leadership in that area. So just a little bit about who we are, so that you have some perspective as to what we're doing. I'm a practicing veterinarian. I'm not nearly as credentialed as most folks that are here at this conference speaking. I'm out in the world, in the field, most days working with pig farmers. I work for a practice called Pipestone Veterinary Services. We have 5 locations in the Midwest. We are a mixed animal practice, but we focus primarily on providing veterinary service to pig farmers in the United States and also internationally. I represent 35 veterinarians in our practice that are distributed across those 5 locations, and we have a number of other specialties that we work on, including biosecurity, research, ways to promote health that hopefully prevent the need for antibiotics in pigs. So a year ago when I was here, I mentioned that we were going to launch a project or service offering called PART, and that is an acronym for Pipestone Antibiotic Resistance Tracker. And PART really is designed to do 2 things. It's first designed to provide a service to our customers who are pig farmers. And then secondly, it's designed to address the real concern around antibiotics, which is not necessarily use but resistance. And so our focus is not on reducing the use of antibiotics as the #1 goal, but it's about demonstrating responsible use of antibiotics on pig farms and also looking at antibiotic resistance at the farm level, which is something that I don't think has been studied nearly as deeply as resistance at other points, particularly with what's been done at NARMS over the last 20 years. So our PART offering was launched on January 1st of this year. It was intended to coincide with the new regulations with respect to VFDs. Today, we have 175 independent farmers that have subscribed to that service. They do pay for the service, and those 175 producers would represent about 6.5 million pigs produced annually. So what does a subscriber get when they subscribe to this offering? Well, They have access to our PART website. Through that access, they can track all of their antibiotic use, which is tracked through purchases. So purchases of injectable medications, water-soluble medications, as well as feed-grade medications. They go into their operations, and we have the sophistication to track that use down to the level of the barn or group of pigs on feed. They get a quarterly report sent to them that basically outlines their usage, and I'll show you some examples of that output in a few minutes. It also includes regular consultation with their farm veterinarian. So as part of the subscription fee, they're guaranteed 2 visits by their veterinarian each year for the specific purpose of discussing their antibiotic use and looking at their trends over time. And then finally, we also launched with this program an effort to begin studying antimicrobial resistance on farm, and in particular the farms that we work with. So I want to declare one thing before I show you a couple of antibiotic resistance projects that we're working on. Remember, we're just a veterinary practice. We do have some specialists in our practice. We have a PhD in epidemiology who's also a DVM. We also have a PhD who is focused in virology as well as bacteriology that has done some work with us as well. But again, we're veterinary practitioners working with the customers that we have, and I'm not here to represent that our methods are the best, but really intended to show you what our effort has been and how we're trying to apply that in the field for the benefit of our producers and for customers. So this first project is a project that's actually being worked on by a veterinary student at the University of Minnesota, and she's teamed up with Dr. Spencer Wayne, who's in our practice, and they decided that they wanted to look at resistance levels of certain bacteria of importance to swine medicine over a period of about the last 16 years. And so what can we learn from culture and sensitivity results at 3 of the main diagnostic laboratories that handle a lot of swine cases? And what can we learn about that? And so this represents samples that were submitted to these laboratories, not just from our veterinary clinic, but from swine practitioners across the United States. And so they looked at these 5 pathogens that would be of concern or high interest to swine veterinarians, and then looked at what their resistance levels or susceptibility levels were to the antibiotics at the right. And so you can see the actual number of isolates represented for each of these different bacterial species on the left-hand side. And it's tried to be represented graphically there. And so here's what their method was, and I'm very open to comments and discussion afterwards if this is just complete bunk or not. But what they decided to do was do just a binary assessment and assign a value, either a 0 or a 1, resistant or sensitive, to each bacterial isolate for each of the antibiotics it was tested against at that laboratory. And then to use that as an index that represents overall resistance over time. Again, this could be valid, it could be completely invalid, but it's a nice project for a veterinary student. And so this is just a slide showing the data and how they assigned it. And then this is the output. And this is, again, a slide that would show the total index, and the black line represents what that index is doing over time. And this is for all 5 of the bacteria combined. And so, interesting. I don't know if it's valid or not, but it's an interesting way of looking at resistance of important pathogens to veterinary practitioners at diagnostic labs. So they then broke that out and decided to look at each of the bacterial isolates individually, and we saw some interesting trends. The first one represented Lactobacillus suis, which showed an increase in susceptibility over time, apparently, based on this method. We also looked at E. coli, which showed a bit more of an up and down and perhaps a more concerning trend here in the last year with respect to the number of isolates that were resistant. And then we looked at another pathogen, Haemophilus parasuis, which showed fairly flat, a flat measurement across the entire time period. And then just a summary of all of the isolates combined. Again, I don't represent this to you as some standard form of measuring resistance, but as a indicator of where we'd like to go and how we'd like to be active in this as practitioners in the field, and addressing the issue of antimicrobial resistance that is the concern of consumers. The second project that we did in the past year was an antimicrobial resistance pilot project done by Dr. Scott D. And Dr. D has a master's in bacteriology and then has a PhD as well. He's the one that should be here presenting this to you and not me. And so what Scott wanted to do within our practice was to look at food safety and coordinate it with the NARMS pathogens. And so what we did is went and took measurements at 2 farms that we work with. One farm is a farm that we consider to have low health pigs and high antibiotic use because that group of pigs required significant treatment with antibiotics. The other barn of pigs we considered high health and very few antibiotics were used, and Scott wanted to collect samples from that facility, namely rectal swabs and environmental samples, culture for the 4 NARMS pathogens, and then look at to see if there were differences in antimicrobial resistance found in those 2 populations that received considerably different antibiotic treatments. And then he also did some work comparing the culture and sensitivity results to genotype and doing some genome sequencing looking for antimicrobial resistance genes. And so I'm going to show you a very simplified look at the results, but essentially in this particular analysis, there weren't a whole lot of differences between the 2 barns as it related to the recovery of the various organisms. And so we found very similar, and what you're looking at is the percent of samples that were positive for each of those bacterial species in that particular barn or population. And then we looked at what were the culture and sensitivity results, what was the phenotype as it related to antibiotic resistance in those populations across the various bacterial pathogens that we tested for. And we basically found there wasn't a lot of difference there either. Then Scott wanted to know, how do we compare what the phenotype or the culture and sensitivity results at the laboratory, how did that compare to genotyping? And it was here that Dr. D collaborated with some researchers at the USDA ARS lab in Athens, Georgia. Dr. Jonathan Fry worked with Scott in doing some genotyping work on 30 of the 138 bacterial isolates that we recovered from those 2 animal populations. And so this is what we found. You can see the number of isolates that were genotyped of each of the pathogens, and then the number of antimicrobial resistance genes that were identified from each of those. And then we wanted to compare to see whether or not the phenotype results were correlated with the genotyping results. And we found what we felt was fairly good correlation. Dr. Fry, I think, agreed with that. And as I attended the NARMS meeting last week, I saw some similar data to this that was being presented, and I think our results are fairly consistent with the data set that was presented last week at the NARMS meeting. So, observations. We made lots of observations. We did observe a difference in the number of E. coli isolates between the two animal populations, but beyond that, we didn't observe a whole lot of differences. We also looked at the different mechanisms of antimicrobial resistance that were reported through the genotyping work, and we also observed class-wide resistance across isolates, some multi-drug resistance within isolates, and we also observed some resistance to drugs that were never used in the population. So, we haven't completely analyzed all of the data. I'm showing you just sort of a brief look of where we're at. I'm sure there's a lot smarter people in this room that could help us with that, and that's one of the reasons that we're presenting it today. We're looking to collaborate in this area with those that are like-minded at better understanding antimicrobial resistance at the farm level. The other thing that we're doing within PART is recording antibiotic use, and I just wanted to show you a little bit of the output there. These are representations of what subscribers to our antibiotic use tracking offering would see. This isn't real data, but it is representative of some of the data that we get. And so you can see here that we can track for a particular producer by month the total grams used per pig for each of the three categories of antibiotics. And I say category, here I'm talking about water medication, injectable medication, and feed medication. We can also look at trends in antibiotic usage over time for individual drugs. And then we also track antibiotic use based on FDA category of drug. And so we can look at critically important antibiotics, highly important, and the non-medically important classes. And then finally, each producer has an opportunity to compare their usage against the aggregate. And so they can see how they stack up in their antibiotic usage compared to the other participants in the data set. They find this quite interesting, as you might suspect. And then we're also looking at, over time, what is the overall usage in the data set? And are we seeing trends up, down, or otherwise? I would emphasize that the participation in our antibiotic tracking piece is obviously voluntary. We treat that information as if it's part of that client's medical record. And so we're not providing that data to outside sources, but it is used for the benefit of that independent producer, and we're hoping that we'll have benefit for the greater discussion about antibiotic use. So that was a whirlwind tour. I apologize, I went through it pretty fast, and I hope I didn't go over too long here. But,
No, we're fine. So, thank you, Dr. Nerem. So we can see that there's a lot going on in where science is meeting farming practices, especially when it looks where the rubber meets the road, and how we utilize those technologies. Do we have time for a couple questions on there? So yeah. While they're finding their way. I'll start with one just in general, Dr. Nerem, with your PART system. Has it met the expectations you were expecting in the last year from when you first introduced it to us?
That's a good question. I don't know if we knew what to expect before we started, actually. And it's still pretty new. We're 10 months in. We've been very pleased with the level of participation. That 175 farmers have decided that this is important enough, we think speaks well of the folks that we work with, and I think that demonstrates that farmers care about this issue. Oftentimes I think it's portrayed that farmers are pushing back, but I think that our producers are open-minded enough to know that this is an issue that affects everyone.
Do we have
Thank you all for your contributions. It's good insights. I will start this by saying in this room we represent a lot of different professions, some Democrats, some Republicans, but we are all capitalists. Somebody paid us to be here. Somebody is paying our way through life, and we, as veterinarians, I think we get caught in a place that's very different than the place that human physicians and human medical personnel get caught, in that unlike the human medical profession, where pharmacy and antibiotic dispensing and using and profitability is absolutely separated and segregated from practitioners, in veterinary medicine, depending on where you are, whether you're an independent private practitioner who is seeing farm animals in the course of practice versus someone who is overseeing a feedlot or an integrated swine or poultry operation, there's a lot of different challenges. And in 1990, when I started in practice, fully 1/3 of my income stream was related to prescription drug dispensing and sales, of which some was antibiotics. If you will remember, in 1990, that was AOL and dial-up internet, and apparently Dr. Google was born in 1991 or 92 and started providing a lot of information to a lot of people who didn't know how to use the information. And with that, we got a lot of self-diagnosis and self-treatment, and I don't need a veterinarian, I don't need an MD, I don't need anybody. All I need is the information. I can solve my own problems. And over the next 20 years, I got to see the prescription drug sales in our practice that was seeing a lot of dairy animals, a lot of beef cattle, and just to point out, in Virginia, the average herd is about 30 cows. So it's very, very disorganized in comparison to a 6.5 million swine in a relatively small geographical area. That being said, prescription drugs are now available pretty readily to anybody who wants them, and margins have gone from something that veterinarians could make a living on to almost non-existent, and we are being called upon to sign the prescription forms for people who take them and use them kind of on their own, and in theory there's some direct oversight. But we've got some great sponsors here, Merck and Norbrook and some others, and they've probably seen that over time the volumes of antibiotics have gone up. And I would tell you that as a veterinarian, we're caught in this situation where we want to use antibiotics responsibly, we want to do all the follow-up, yet the only way to continue to have any profitability is those increased sales at lower margins. So I think we need, as an industry, to try to figure out how to address that, in that it is a great source of inappropriate antibiotic use in cattle in particular, this sort of pipeline system that is developed. And if you have any comments on, I assume that in the fine print of what I see you doing, there is a binding of these clients to your practice at Pipestone. You are monitoring the antibiotics that they are purchasing through you, and that is a brilliant strategy.
Well, I can tell you that it wasn't our strategy to design this to sell more drugs. And so we do sell antibiotics through our practice, as do most practicing veterinarians in food animal practice that I know of today. And so it is one of the advantages that allows our program to function, is that we have that knowledge of purchases because it comes to our operation, it comes to our clinic. And the VFD piece ties in nicely because now we're signing the VFDs in order for them to put medication in the feed. And so it ties the information flow. But I would say that the profitability of our particular practice is not necessarily tied to antibiotics. In fact, when we sit down and look at it, the income streams that we have, antibiotics would be low down the list, actually. And so, again, we're all about promoting responsible antibiotic use. We still would like to be able to continue to provide antibiotics to our producers because we think we can do it in an ethical and a biosecure way, which is very important in the swine industry. But we also also are busy promoting other things like vaccinations, herd health consultation. We firmly believe that a veterinarian's value is not providing drugs. A veterinarian's value is helping create environments for animals that reduce the need for antibiotics and improve the welfare of the animal and improve the profitability of the farmer. And so we're very much interested in providing service to improve all of those things and hopefully develop revenue streams that reward us for that, not just the sale of the drug. If that answered your question or not.
Question?
Hi, so my name is Sarah. I work for Center for Science in the Public Interest, which is a consumer advocacy group, and we were involved in a lot of those campaigns to get restaurants to change their purchasing policies. And I often hear a lot of frustration when it comes to discussions about the market and consumer demands, and I'd like to say we're open to talking with producers. That's why I'm here today, and if you have, if you want to talk with and get a consumer perspective on that, please come to me. I had a comment and then a question for Dr. Carver. The comment is just because I'm not going to be at the cocktail party tonight. I wanted to comment on residues. And I was wondering if, well, this isn't a question, it's a comment. If you looked into the Center for Food Safety lawsuit against Sanderson Chicken, they did raise, evidence that there were both violative residues and residues from drugs where there was no federal standard set. So I think that's not necessarily a closed question at this point. And then my question was, I thought your slides were great. They really demonstrate some of the changes and progress that have been made in the poultry industry. I was surprised that it was kind of a gloomy presentation, and I had coming here today, I thought, poultry was an area where we'd made the most progress, and I was more concerned about what was happening with beef and pork. And in particular, in Europe, where they've shifted a lot of their practices, they found that it was really zero cost for chicken to go to a no routine use of antibiotics model. And also Purdue, they only have to treat 3% of their birds with antibiotics, so it seems like they're not really getting sick at high rates. So I was wondering, with all, I know that there's a lot of potential for critique and sort of hypothetical questions about whether feed prices will rise and that'll change the economic model, but overall, do you think this is a viable model, given all those concerns that you raised? And, can you just provide comment on that?
Yes, I do think it's a viable model. I'm sorry it was gloomy. But a lot of what I said was based on surveys that I did of veterinarians, and I do think that at this point, with some of the new mandates, that they're kind of caught in the middle. And I think that over time, we're learning how to grow antimicrobial-free birds. It's been a short period of time. The markets are really sort of demanding it more quickly than we're able to provide it. I do think it will work. It does work in some companies that's all they do, and they they build new facilities, they select their growers very carefully, and so they have been able to be successful with that. But, it's a fledgling sort of a way to grow birds, and it is getting better. There are a couple of diseases that really super frustrate the veterinarians because they cannot treat them. And they are diseases that really can wipe the flocks out totally. But if they don't wipe the flocks out totally, the feed conversions and the things that we measure about efficiency, they really can't reach those. So I guess maybe I was sort of trying to reflect how they feel right now. I think as time goes on, they will probably, with all of the things that they're looking at in terms of botanicals and things like that, if they work, and they are seeing some promise with those, they will be able to, people adapt. I mean, the markets will have to adapt, if nothing else. But I think that, it'll be viable. It's just a matter matter of time.
Well, great. Thanks to our panel, and as we can see, we have a very diverse topic here with a lot of moving parts, and we appreciate their participation. So thank you again.